Hello and welcome to the Qt 6.9 Major Feature Updates webinar. In this webinar, we will be going over an overview of many of the new features in Qt 6.9. My name is Adam Keene. I'm here alongside my colleague Ben Hadra, and here's an agenda for what we'll be looking at today. First, we'll be going over Qt Graphs and some of the updates in Qt 6.9, followed by CuteQuick, emoji support, CuteQuick controls, Qt GUI updates, and platform updates. So with that, we'll go ahead and get started with Qt Graphs. So there are a few updates in Qt 6.9 regarding Qt Graphs, mostly broken up into some 3D updates and then some additional 2D updates that we'll go through. So starting with Qt Graphs for 3D updates, some of the updates include additional types have been added to render data in splines. So there are now spline series available in your 3D graphs by these QML types such as spline 3D series and C++ types like QSpline 3D series. Along with 3D spline graphs, there are also minimum and maximum rotations in the X and Y directions that can be specified for all different types of 3D graphs. So this applies to bars 3D, scatter 3D, surface 3D, and so on. These are specified by the max camera X rotation and max camera Y rotation properties that you can see on the right-hand side in the code. Some additional updates to axes for 3D graphs include label sizes, which can now be adjusted for each axis. So you can see the QML type and property listed here, the label size property within the abstract 3D axis type, as well as the same label size property for Q abstract 3D axis. So this can be used to adjust the size of labels for each axis, as well as labels for axes being able to be scaled based on the number of labels. So the last property in the bottom of the screen here is scale labels by count for both abstract 3D access in QML and Q abstract 3D access in C++. And this allows you to, again, scale the label size based on the number of labels. So if I flip over the code here, we can see a 3D graph example, and we can demo some of these kind of behaviors. So the first behavior that we will talk about is the X rotation and Y rotation. So if we click these buttons here, we're basically specifying the maximum X value and Y value for these rotations. So our maximum X rotation here is 120. So we're rotating our graph just that amount. And then if we click for rotate Y to move that 60 in the Y direction, we can see the graph moving a maximum of 60 in the Y direction. We can also see the labels on the axes of this graph. So the scale labels property is enabled right now. So it's set to true with this switch here. And then we can increase the amount of labels with the slider, and we can see that the size of those labels is scaling accordingly. If we disable the switch, we won't see this behavior. We'll see the basic behavior where the labels just stay the same size. So moving forward to some additional updates for 3D graphs and Qt Graphs, there's now the ability to inject a 3D graph into a View 3D in a CuteQuick application. So the way this was done was the root node property was added to graphs item 3D, which allows us to return a pointer to the root node of any 3D graph. With this root node value, this pointer, we're able to use that as the value for import scene within a View 3D, so the import scene property within a View 3D, to inject that 3D graph into a separate View 3D. As well as View 3D injection, we also have transparency support added. So in previous versions of Qt, there was transparency support for bar graphs and scatter graphs, but now there's also additional support for surface graphs. This includes order-independent transparency from CuteQuick 3D, and we can specify the accurate or approximate transparency techniques with this transparency technique property within graphs item 3D. So if I flip the code around on the right here, we can see I have two graphs which are imported into separate View 3Ds. We can see a couple of different 3D scenes, and these graphs are surface graphs, which are now able to be transparent. As I adjust this slider, we can see the transparency working properly for a surface 3D graph. Lastly, we'll go over some Qt Graphs for 2D updates. So one of the major updates for Qt Graphs for 2D is this zooming and panning support. So you can see a list of a couple properties on the first bullet point here. Zoom style, which is used to just enable or disable zooming. Zoom sensitivity, which can control the speed of our zooms. zoom area enabled, which allows us to enable mouse and touch dragging for zoom, and then a zoom area delegate, which determines the QML element that is drawn when we drag, would do some zoom dragging. We can also align our axes within 2D graphs. This is done by the alignment property. So axes can now be aligned to left, right, top, or bottom, and then we can see the QML type, the QML property, which is the alignment property within the abstract axis, and then the alignment property on the C++ side within Q abstract axis. Additionally, there is more input handling. There are more than is just listed here, but there is plenty of input handling added to area, line, pie, and scatter graphs, so such as clicked signals, on double clicked, etc. We can see there is additional input handling which wasn't previously available. Lastly, for 2D graphs, we can now get the rectangle area a graph will be drawn in. This is done with the plot area property within a graphs view or a Q graphs view. And this allows us to get information about the rectangle that the graph is actually drawn in. So we can see on the right side here, we have some code to enable some of these zoom properties that we discussed, as well as the alignment. We can see these in action if I turn around the code here. We see a basic 2D bar graph. And first we'll talk about the axes. So if I select this button in the top right, we can see I'm going to change the alignment of my axes from top and right to bottom and left. We can see this. And switching back and forth between those two alignments, we can see these axes alignment properties in action. We can also get the rectangle area that a graph will be drawn in by clicking highlight plot area. We got that information about, we can see we printed it here in the middle, about that plot area, and then we just highlighted a rectangle of that size as well as output the data so that we can see the actual area that this graph was drawn. And then we can talk a little bit about zooming. So this slider here is going to control our zoom sensitivity. So as we increase this slider, we can get a very fast zoom, which is a little hard to see because it's going so fast, but a very fast zoom, which is extremely sensitive. Or if we lower the slider, we can see a much more slow controlled zoom, but you can adjust this per graph. And lastly, if we reset the zoom, we can show the zoom area delegate. So if we do some zoom dragging and create a component, this is our QML component that is used to show that zooming. You saw that white rectangle kind of flash before we did that zoom, and there it is again. That is the zoom area delegate that we defined for our 2D graph zooming.
All right, thanks, Adam. So the next topic we're going to be discussing will be the updates to the CuteQuick module in 6.9. So as a quick agenda, we're going to start by talking about the new safe area QML type. Then we'll move on to the shear QML type, the rectangular shadow type, and then we'll talk a little bit about SVG animations using CuteQuick vector image. So first, to talk a little bit about the new safe area QML type. So the safe area QML type is going to be an attached type, which provides some information about the areas of a window where content may risk overlapping system UI elements. So this is going to be primarily useful on mobile devices where these types of system UI elements are very common, kind of as we see here on the right-hand side. We can see an iOS device where we've got kind of the bezel at the top. We've got like the battery and Wi-Fi icons. And then at the bottom, we've kind of got the line to return to the home screen. So these would be examples of system UI elements that we probably don't want our application's user interface to be overlapping with, as it will be kind of confusing for the user. So the safe area essentially informs the developer about the area within the application where you're not going to be risking overlapping with these elements. So we can see kind of up at the top and bottom, we have an overlap risk, where in the middle, we have a safe area. And this will be coming directly from the system itself. So whether we're working on iOS or we're working on Android, we're going to get, well, slightly different margins for the safe area as they have slightly different space defined for system UI components. All right, so the way that this can be worked with is by using the safe area QML type, which has properties to get information about the safe area as well as modify that safe area. So basically we have two sets of properties. We have the margins property within the safe area. And this basically just returns the value coming from the system to inform us about the safe area. So this will basically tell us the number of pixels the top, bottom, left, and right side of our application where we may risk overlapping with system UI elements. As we can see, we're using this within this simple application here. We've got a rectangle embedded inside of another rectangle, where the inner rectangle is using the safe area margins. As we can see, we're setting the top, left, right, and bottom margins based on the safe area margins of the same properties. And therefore, we are going to see those margins applied to the inner rectangle, where the outer rectangle will be taking up the entire space of the UI. We also have the ability to add additional margins, and this essentially allows us to modify those margins as needed. So if when we use the kind of system margins, maybe we want a little bit of extra space at the top and bottom of our UI, we can modify these margins with the additional margins property. So since this application actually is primarily built out for a mobile device, I've actually got an Android emulator here to demonstrate this application. So we can see this is a fully working Android emulator. And we can see at the top and bottom of our application, we have that outer rectangle visible, which is not using the safe area margins, and therefore it is coming through as visible. And then the inner rectangle we can see here is using the safe area. And we can actually see I printed out the information about those margins. So we can see we've got 24 pixels at the top and bottom of the application, which are considered unsafe or not within that safe area. So they are overlapping with the system UI elements, as we can see. And then if I click the apply additional margins, we can see we can modify those margins a little bit. So I just added 10 pixels of space to all those margins. And so we can actually see we also have the left and right side margins as well, even though kind of by default, those there is no margins or unsafe area in the left and right side of the application. We can still add margins there if we want to. All right, and that is the safe area QML type. All right, so moving forward, we added a new type called the Shear QML type. The new Shear QML type is going to allow us to apply a transform, a shear transform to any QML item. And basically, this is going to transform it by a two-dimensional shear type matrix, also known as a skew transform. So we're going to be able to apply skew transforms to any QML item. This does need to be applied within the transform property of an item. And the shear factor can be modified using an XY factor or an XY angle. So basically the XY factor is going to be a scalar value associated with this transform, which is going to scale the amount that is being transformed. So we can kind of see how that calculation is done here for the X and Y factors. And then we also can do this using an angle. As we can see here, these are essentially going to be functionally equivalent, but the math is worked out a little bit differently. So whichever kind of your preference is, if you want to use a scalar factor or an angular factor, they're both going to allow you to produce the same type of transform. Just gives you kind of different options in how you want to produce that transform. So here, if I flip over my example, we can see I'm going to be applying this shear transform to a rectangle, but it is worth noting that this is applicable to any type of QML item. So we can do this with things like buttons or sliders or any of the controls which inherit from an item. You can still apply these transforms too, but I'm just going to use a rectangle for simplicity. So we can see as I increase the X factor, we're going to kind of increase the transform along the X axis. And then as I increase the Y factor, we can actually make it disappear, but we can see we're increasing the transform along the Y axis, as can be seen there. And if I click this switch here, we can switch over to an angular transform, which we can see we basically produce the exact same results, but now we're doing this using an angular value rather than a scalar value. And that is the new Shear QML type. So the next topic to talk about will be the rectangular shadow QML type. So the new rectangular shadow was added to the CuteQuick effects module. And basically it is a rounded rectangle with a blur applied to it. And it is intended to be used behind an existing component to give it a shadow effect. And basically this is going to have superior performance to the general multi-effect based shadow. So this was already something that was possible within the multi-effect module. But this is basically just going to give you superior performance for something that we saw was very common within multi-effect. So we've got various different properties. We have the offset X and Y, which provide an X and Y offset from the base component. the radius, which is just going to round the corners relative to the size of the rectangle, blur, which is a scalar value to determine how blurry your rectangle is going to be, and then spread, which is a scalar value which increases the size of the rectangular shadow. So here we can see I've got a rectangular shadow component, which not shown in this code snippet here is the base component of the rectangle, which is being used kind of in front of the rectangular shadow. So if we flip this over, we can actually see right here, this is the base rectangle. And then as I increase my X and Y offset, we can see we're starting to display that kind of hidden rectangle that was behind it. And then as I increase the blur, we can see we're going to start to get kind of a shadow looking effect. And then as I increase the spread, we're going to increase the size of that shadow and very quickly be able to produce a really nice looking shadow behind that rectangle, giving our UI some really nice depth that's extremely easy to produce using this new rectangular shadow QML type. All right, so the last topic within CuteQuick is going to be the updates to the CuteQuick vector image module. So the CuteQuick vector image module was actually added pretty recently in Qt 6.8, and it is used to load an SVG file and display it within a CuteQuick scene. Now, some improvements have been made here in 6.9 as our continued commitment to improve this module. And now we've added the preliminary support for fill, stroke, and transform animations within an SVG image. This is essentially meant to match the current smile animation support as part of Qt SVG. So the other kind of module we have, which can handle SVG files, did already support these animations, but now CuteQuick Vector Image supports them as well, making it easier to inject within a CuteQuick scene. And this is going to enable our SVG images with vector image to take advantage of the hardware acceleration you find in most CuteQuick applications, allowing us to get some improved performance out of our SVG-based animations. So here we see, although there's no new properties, we do now support in SVG. So this animated twisted rounded block.svg file has a transform animation built into it. So when I flip over this image, we can see we do have that transform animation being applied within this SVG file and with this CuteQuick vector image. And of course, we have some nice scalability, as is often the advantage of using SVG files. We can scale it up and see we still get a really nice animation as we scale it up or reduce the size, as can be seen there. All right, so that covers everything as part of the CuteQuick module updates, or at least the major updates. So the next topic to talk about is going to be some improvements to our emoji support in 6.9. So there's going to be two major updates to talk about, one of which is going to be the updated emoji segmenter, as well as the update to our font format support. So starting with the updated emoji segmenter. So the big place where this comes in is certain characters, which are text by default, can be turned into an emoji by appending a control character. So for example, here we see the 2708 is basically a kind of black plain text looking image by default, but we can add the control character FEOF to turn it into a colorful emoji as seen right here. Now, this did cause some problems in previous versions of Qt due to the text being split into separate script items. And therefore, the kind of main text and the control text were interpreted separately. And therefore, we got kind of incorrect text produced or glyphs produced by some previous versions of Qt. This had been handled in kind of an ad hoc manner, resulting in some broken corner cases. So this new updated emoji segmenter has sought out to fix this entirely. And this is basically a Google emoji segmenter. And this is a small parser for emoji specifications in Unicode, allowing us to detect substrings properly. So we kind of lose all of those corner cases where we saw some broken emojis before, and now we should see better handling of these control characters. That being said, this segmenter can be disabled as it may reduce some overhead when it's known that your text will not contain any emojis. So setting the environment variable Qt disable emoji segmenter can disable this, or passing into the command line the no emoji segmenter argument can also disable it. And again, if you know your application will not use any emojis at all, this can reduce overhead a little bit. So if I flip over this code, we can see our new handling of the control character. So I've got two examples of text. So in the top, we see the U plus 2708 produces this black plain-like image, but we apply the control character FEOF, we get that nice colorful emoji. And I can kind of cycle through these. We can see we get a very similar result with this envelope character, and we get a colorful envelope emoji. And as we go on, even ones that are unaffected by the control character, we can see still displays them properly. And as we cycle through these emojis, we can see the ones that are affected by the control character. We get a nice clean adjustment to the type of emoji that is displayed there. All right, so the next update is going to be the updated font format support. So as of Qt 6.9, we have three emoji font formats supported across all platforms, and that is the CBDT, Color V0, and Color V1 are now supported on all platforms. So hopefully this should prevent the need to ship different emoji fonts based on your platform. Some information about these different types of formats. So CBDT, these are emojis with typically a pretty nice looking gradient, but have some scaling issues. So usually would only be useful for very small text. Color V0, these are more flat looking images due to only allowing single color fills, but these do scale a lot better. And then color V1, which allows color gradients as well as improved scalability. And then all emoji text also now has some improved anti-aliasing. So again, kind of going along with improving scalability of emojis, we're now going to see cleaner edges of those emojis when we scale up their size. So here we can see we're using various different text with our different font families of color V1, color V0. So if we flip this over, we can see we've got our different emojis displayed here. So mainly looking at color V0 and color V1, we can see we've got the flat but scalable emoji here in the center and the still scalable but having a nice gradient present in color V1. And if we kind of flip through these, we can see lots of different types of emojis are supported, as we can see.
Thanks, Ben. Next, we'll talk about some of the updates to the CuteQuick controls module. And really, those updates are focused around the new context menu QML type. So, as I mentioned, there's a new QML type called context menu that has been added. And this new QML type can be attached to any component that inherits from item. And what this does is it shows a context menu upon a platform-specific event. So this can be like a right click or clicking the context menu key. And it will create, or context menu will create a menu upon request. So this menu generation is optimized not to create the menu at the application startup time, but basically when you right click on your item that you've attached your context menu to, it will create that menu lazily. One thing to note is if you give an ID to the context menu.menu property where this is defined, if you give an ID to the menu in that line when it is defined, this will negate that optimization. So just keep that in mind. But it is possible, like in this example to the right, to share a menu amongst multiple attached context menu objects. So this allows you to reuse a single menu for various items. So we can see my menu is defined on the right side here, and then attached to this rectangle with the context menu.menu property. So if I flip this code around, I can see that there are actually two rectangles here that are going to share that one common menu that we had defined. So if I right click on either of these rectangles, we'll see the same context menu, which has a couple of basic functionality that's going to shrink and grow these rectangles. These two rectangles are sharing that same context menu. We're also printing the results of where this request for the context menu was made with the onRequested signal handler for context menu, just printing out those coordinates showing where that click actually happened, where that request happened. Continuing on with context menu, it is good to note that text field and text area have default context menus. So if you were to right click on a text field or text area, you would see this default context menu, but it is also possible to customize context menu.menu if you don't want to use that default context menu. Customization is not going to lead to an additional context menu being opened. It is just going to override the default menu. Similarly, context menus will not interfere with other existing menus. So if you do have a menu that is opened by some other means, we've listed here like a signal handler, context menu will not open at the same time. And what this does is allows for legacy applications that were written before context menu existed to continue functioning as expected. So we can see if we flip the code around here, we'll see a text area and a text field. So if we right click the text field, we'll see the default context menu, which has some cut, copy, paste, select all functionality. We pasted in Qt 6.9 there. And then we can also override that default menu, which does exist for text area, but we've created our own. So this one just is going to allow us to print a hello world to this text area or delete that text. But you notice not both of the menus were displayed at the same time. All right, and moving forward, we'll talk about some Qt GUI updates, and this is mostly going to pertain to Qt RHI improvements. So Qt RHI, or Qt Rendering Hardware Interface, is an abstraction for hardware accelerated graphics. So it supports a couple of different platforms like OpenGL, OpenGL ES, Direct3D, Metal, or Vulcan. So really the updates to this module are happening within the Qt RHI or the QRHI class within the Qt GUI module. So we've listed some of the performance benefits here. So like this significantly enhanced performance in multi-sampled rendering on tiled GPU architectures. So there is this variable here with a very long name with the GL_ext multi-sampled render to texture variable. That's basically going to be used whenever possible within OpenGL ES. So some of these benefits are just going to apply to some of the different platforms like OpenGL, ES, Metal, or Vulcan, etc. So this next update is talking about reduced lag when you are interactively dragging items on Windows. We are able to reduce the CPU load and latency with this update to QWindow update requests, which are now driven by dedicated vBlank watcher thread. So this is basically reduced lag, which applies to Direct3D 11 and Direct3D 12. So some additional RHI improvements, the support for variable rate shading, which enables dynamic foveation support for CuteQuick 3D XR, and this is going to apply to Direct3D 12, Vulcan, and Metal. We've also added support for more integer and depth texture formats, as well as integration of external rendering or computing engines that rely on multiple threads and require synchronization with the scene graph renderer. This is basically done with support for passing application-provided weight or signal semaphores, and this is a Vulcan update.
All right, thanks, Adam. So our final topic for today is going to be talking a little bit about some of the platform updates that came with 6.9. So maybe we're going to be talking about some of the desktop and mobile platform changes that are coming in 6.9, as well as the boot to Qt platform changes. And this being a non-LTS release, we try to keep it relatively light with most of these updates, but there are some changes as can be seen. So starting off with Android. So Android 15 is now supported, so that brings the total Android support from Android 9 through 15 as of Qt 6.9. We've also added easier interactions with Android managers, such as the battery manager. So we've got some improved interactions there. And then we've also added some Android app icon name compile SDK and permissions. These can all now be managed through the CMake API. So basically you can set like your app icon or application name just using the CMake API. So that's some nice quality of life improvements there on Android. Some minor updates to iOS. So we now have the new rolling support, which aligns with Apple's commitment to forward compatibility. And essentially what this means is it's going to make some older versions of Qt supported on newer versions of iOS and Mac OS. And this is going to be applied to 6.5 and 6.8 retroactively. So even though this is, talking about 6.9, that will apply to 6.5 and 6.8. So our two previous LTS releases will see this change as well. As far as Windows goes, Qt does support Windows 10 and 11. That was, of course, applicable to 6.8 as well, but worth reiterating. We also have Windows App SDK support and an improved support for Qt Web Engine and Windows on ARM. And then finally, talking about Linux, we actually have no changes here in 6.9, but I would expect to see some relatively significant updates coming in 6.10 and forward, although nothing has been released as of 6.9. All right, so now talking a little bit about boot to Qt. So just as kind of an overview, we're going to be talking a little bit about our different tier supports. So we have tier 1, tier 2, and tier 3 when it comes to boot to Qt. So tier 1 represents the highest priority. So any issues that occur within a tier 1 supported device is going to receive the highest priority. And this will be fully covered underneath standard support, and any QBSPs for our tier 1 devices will be released and available inside of the Qt Online installer. Tier 2 is a small step below that, where you still have a higher priority than Tier 3, but slightly less than Tier 1 when it comes to issues. And these devices are going to be covered under premium support. And these releases will also be available via the online installer. And then finally, there's Tier 3, which is kind of our lowest, but still technically supported support of boot to Qt devices, where this hardware is not going to be regularly tested, or at least not as regularly tested as Tiers 1 and 2. And at times, the QBSP packages may be acquired from the vendors and not actually come from us, the Qt company. And some of these releases will still be available via the Qt Online installer or your customer portal. But again, there may be times where these packages do need to be coming from the vendors rather than from us. So that's what Tier 3 is. So I wanted to bring that up as when we talk about boot to Qt platform updates, a lot of this is kind of shuffling around of those tiers. So before talking about those tiers, first off is to say that Yocto 5.1 Styhead is now supported as of Qt 6.9, so very important when talking about boot to Qt. And then talking about some new and upgraded tiers. So the NVIDIA Jetson AGX Orin Developer Kit has been updated to Tier 1 support, and I believe this was in Tier 2 prior. So basically, this is becoming a bigger focus of ours, and you're going to see improved support if that is a device that you're using. And then we also have added a new support in Tier 3, which is the Qualcomm RB3 Gen 2 Vision Kit. So previously this was an unsupported device, and now this is supported inside of Tier 3, which is kind of typically the kind of entry point for new devices to go into Tier 3. We do unfortunately have some downgrades as well. So the Tordex Apple's IMX6 has been downgraded from Tier 1 to Tier 2. And then we've also downgraded the or a number of different NXP IMX8 devices, these being the Mini, Nano, and Plus versions, are downgraded from Tier 2 to Tier 3. And then finally, in 6.9, there are a number of devices which have lost their support. So these were all Tier 3 devices that we can see here, which I won't list them all out, but those have all been removed from Tier 3 support as of Qt 6.9. And that actually covers all of the topics for today. So with that, we can move over to taking some questions. And I believe there probably are some in the chat, which we can start answering now.